If we take a square matrix, 3 by 3, the determinant of A is equal to the determinant having the same elements as those of the matrix. So it's det 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we remember, we discussed in a previous video that we can determine that by taking this top row, so it's 1 times the determinant of the minor, so 5, 6, 8, 9, plus 1 minus, so we alternate plus minus plus minus, so 2 determinant of 4, 6, 7, 9, and then plus, so it goes plus minus plus 3, and then the minor of that 4, 5, 7, 8. So to work that out, we have 1 times, if you remember, it's this diagonal, so 5 9s are 45, 6 8s are 48. Okay, minus 2 times 4 9s are 36, minus 6 7s are 42, and then plus 3 times 4 8s are 32, minus 7 5s 35. Okay, so we get the value of minus 3, 36 minus 42 is minus 6 times minus 2 is plus 12. 32 minus 35 is minus 3 times plus 3 is minus 9. Okay, which equals minus 3 minus 9 is minus 12 plus 12, which equals 0, which is a special case. The determinant has a value of 0, and it's a special case. This is called a special case where the determinant is 0 is called a singular matrix. And the reason, okay, there's a theorem which says that these row 3 are all multiples of a constant, so that's a special case. But ordinarily that determinant will come out to be some number. It just happens to be 0 in this case because that's a special case. So the cofactors then, so if A is a square matrix, the minor of this element is 5 6 9. We can look at these determinants of the minors, so these values here, which is minus 3 in this case, 36 minus 42 is minus 6, and then 32 minus 35 is minus 3. And then multiplied by the sign, so this is the coefficient here, this is the coefficient 2, and this is the coefficient 3. But the signs go from, starting from the top left hand corner, plus, minus, plus, and if it was more, minus, etc. And then minus, plus, minus, plus, minus, dot, 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 etc. Plus, minus, plus, and dot, alternating pluses and minuses, starting with a positive in the top left hand corner. So we call these the cofactors, and that is a combination of the determinant of the minor, so that's the minor, which is, if we're looking at this value which has this row and this column, it's the remaining determinant of the minor. This is the minor 5, 6, 8, 9, which gives us this 45 minus 48, and then multiplied throughout by having the sign corresponding to its place. So we say that the cofactor of this is plus minus 3. The cofactor of this is minus 6. The cofactor of this is plus minus 3. So this is the cofactors of that top line. Then, for example, are minus 3, minus 6 is plus 6, and then plus minus 3 is minus 3. And we build up this matrix, which we call the matrix of cofactors. So continuing through for the cofactors of this matrix A, then we can see that this next row and column has a negative, so that's equal to minus, and then the minor of that is 2, 3, 8, 9. So we're working out the cofactor of this 4 value, which gives us 2 9s are 18 minus 24, 3 8s. Okay, so that's minus this lot here. 18 minus 24 is minus 6, so that's minus 6. So this cofactor then is minus times a minus is a plus, so that is plus 6. Okay. Moving on to this one here, we take the determinant of its minor, 1, 3, 7, 9. 1, 9 is 9 minus 3 7s are 21. So that gives us a value of 9 minus 21 gives us minus 12. And that is in this location here, so that is positive minus 12, so that is minus 12 as the cofactor, plus minus 12 is minus 12. And then this value here, that has a determinant the cofactor of the determinant, it is the determinant of its minor, which is 1, 1, 2, sorry, not 1, 3. So 1, 2, 7, 8, which gives us 1 times 8 is 8, minus 14, which gives us minus 6, and that is in this location here, which is minus plus minus this one here. So it's minus minus 6, which is plus 6. Okay. Coming down to this one here, the cofactor of this 7, its minor is, let's find some space up here, 2, 3, 5, 6. 2, 3, 5, 6 gives us 12 minus 15, which gives us minus 3, and we're here, just check where we are. Yeah, we're down here, so that's plus minus 3, which is minus 3, so that cofactor is minus 3. The cofactor of this is the determinant 1, 3, 4, 6, which gives us 1 times 6 is 6, minus 3 4s are 12, which gives us minus 6, and we are looking at this 8 here, which is has a negative, so it's minus minus 6, which is plus 6, so we have a plus 6 in here. And then finally, this last one here is the determinant of 1, 2, 4, 5. So 1, 5 is 5, 2 4s are 8, minus 8 gives us minus 3, and we are in this location, which is positive, so plus minus 3 is minus 3, so we have a minus 3 here. So that is our cofactors, our matrix of cofactors of this matrix up here. So that is how we go about calculating the cofactors, or the matrix of cofactors.